Another name for slope is average rate of change. When we talk about slope, we're talking about how steep the line is or the slant. So its definition is basically average rate of change. And it's defined by a few different directions. We can look at it as stairs. And when you think about a stair step, you rise and then you run, you rise and then you run, you rise and then you run. And so when you look at stairs, let's draw it on the graph over here. Let's suppose this is my coordinate. I'm going to rise 2, run 1 to get to my next point. Rise 2, run 1. When you go upstairs, you always rise before you run. So the slope in this case is rise 2, run 1. So it's the rise over the run. So in the graph next to that, it's rise 2, run 1. We also define it a different way. Change in y over change in x. If you look at y, y is the axis that goes up and down, so it's equal to my rise. X is the axis that goes left and right, so it's equal to the run. So that's where we get rise over run. And that little triangle delta is called change. Now, slope can be steep. So we could have a slope that maybe has a point here, and we rise 1, 2, 3, 4, 5, and run 1. If you notice and compare the slope on this line versus a slope where I rise 1 and run 5, notice the difference when we talk about the slant of the line. This is rise 1, run 5. The first graph was rise 5, run 1. Quite a bit different in the steepness of the line. So the formula for finding slope, because we said it was rise over run, or in other words, change in y over change in x. If you think about change in y is taking one coordinate of y and subtracting the other coordinate of the second point over the x, which is the run piece. Now these little subscripts down below just are telling you which point you used first and then which one you used second. And so if we take an example here of 2 points, if I wanted to, I could plot them on a line. And if I did that, 5, 3, and 2, 1. If I look, there's my steepness. How many did I rise? Well, I rose 2, and how many did I run? 3. Now, not all the time do we want to graph 2 points. So what we're going to do is apply the formula. I'm going to call the ordered pair 5, 3, x1, y1. So this is going to be x2, y2. According to my formula, it says take the y coordinates, 1 minus 3, divide by the x coordinates, 2 minus 5. Remember your integer operations. 1 minus 3 is negative 2. 2 minus 5 is negative 3. 2 negatives make a positive when you divide. Now this formula could have also had my first point minus my second point, and likewise in the denominator. It doesn't matter which direction you're going to subtract. Let's try another example in finding slope using our formula. Change in y. So let's go ahead and label these. So I might want to go y1 minus y2, which is a 3, negative, over, let's see, if I start with y, I must start with y1, I might start with x1, which is negative 1 minus 6. Equating this, 2 negatives together make a positive, so I get a 1, and negative 1 and negative 6 is going to be negative 7. So the slant of the line here is down 1, and let's see, over 7. So let's see, we could also think of it as go up 1 and negative 7, or we could also think of it as going down 1 over 7, because these two fractions are equivalent. We could also write the negative right by the divide line. So notice we have a positive slope in the first example and a negative slope in the second example. So what do they look like when they are positive slopes? If I go ahead and graph a picture of a positive slope, reread math just as we do English from left to right. There's my line with a positive slope. If I had something driving up that line, it would be going uphill. So that was a slope such as y2 run 3. If I look at a negative slope, negative must mean going down. So from left to right, if I had an object traveling on this line, I would be going down. That was at negative 1/7. So notice this is going down. And we have kind of two special cases of slope. A slope of 0. That means that my vehicle is neither going uphill nor is it going downhill. So the vehicle is sitting on this line, traveling straight. No slope to the line. So let's see, if I look at this, there is no change in y. I'm not rising any, but I'm running. I'm moving from one location to the next. So this would be a number maybe such as 2. That fraction is equal to 0, which means there is no change in y. The slope is 0. There is no slant. If I look at an undefined slope, that's going to be this vertical line. And if you think about it, if you have a vehicle on a perfectly vertical line, there is no way you can travel on that line. It's impossible. Where in this case I could travel, my road is just flat. So if I look, let's see, I'm changing in y because I have a rise. So I have maybe a change of 1 in y, but I have no change in x. So there is no change in x. And when you have 1 over 0, that is undefined, does not exist. There is no slope. Now look at the difference here. No slope and 0 slope are two different things. 0 is a number. No slope means it does not exist. So you must be careful about where the 0 is in your fraction. If it's in the numerator, it's going to be a number right on. It's going to be 0. If it's in the denominator, no, that's not going to be divisible. You can't divide by 0. 1 divided by 0 is going to be undefined. And if you look at it visually, you can see your slope here. This is impossible for a car to go up that road. If you think about it in terms of population and time, it means that I'm changing, maybe this is at 3 hours, I'm changing population without moving time. I'm in two places at the same time, which you cannot be.